set up mole conversion or dimensional analysis problems, you must clearly identify what values and units you begin with, what I call the given, and what units you want to end up with, what I call wanted. It is helpful for me to write these things down. Next, write out conversion factors as equalities that you will need. If you need a molar mass, calculate it. Next, set up the railroad math so that you start with the given and arrange all conversion factors as ratios so that the unwanted units cancel out. Remember, the molar mass must be calculated, and it is easiest to do this before you attempt the conversion math. It is incredibly important to include units in your railroad math so you know how to arrange the conversion factors, and incredibly important to include units in your final answer. The very last step is to make sure your answer makes sense. Since Avogadro's number is a magnitude that is far greater than what we deal with in our everyday life, let's look at some numerical contexts. When you are calculating the mass of a substance, it is generally not going to be too terribly large. Most of the masses that you calculate in this class are on the order of magnitude of masses that could be weighed in the laboratory. The mass of planet Earth is estimated to be 5.97 times 10 to the 27th grams. If you end up with a mass that is on the order of magnitude of Avogadro's number, or our planet, something is usually wrong. When you are calculating the mass of a very small particle in units of grams, the value is going to be very, very small. For example, the mass of a hydrogen atom is 1.66 times 10 to the negative 22 grams. If you end up with a negative exponent for a number of particles, your answer is wrong. Particles are whole and counted. They do not exist in fractions or negative exponents.